Hey everyone, welcome to Web3 Deep Dive. I'm your host, Rachel Wolfson. This show focuses on real-world Web3 use cases to help you better understand how this technology is being applied today and how it may be applied in the future. If this sounds interesting, please be sure to subscribe to the show so you stay up to date with all the new episodes. Before getting started with today's episode, I'd like to thank Worsta for making Web3 Deep Dive possible. Worsta is a global technology consultancy with headquarters in Austin, Texas, and Quito, Ecuador. Worsta works with enterprises to help them make sound business decisions on all of their core technologies. And before we get started with the show, I also just want to remind you guys that Web3 Deep Dive is for educational and entertainment purposes only and does not offer any forms of financial advice at all. Without further ado, let's dig deep into Web3. In this episode, I'll be speaking with Evan Shapiro. He is the CEO of Mina Foundation. We'll be talking about zero-knowledge proofs and how this applies to Web3 and AI. Let's get started with today's episode. Hey, Evan. How's it going?
Good, thank you.
Yeah, good to see you. Thank you for joining us today on Web3 Deep Dive here in Austin.
Yeah, thanks for having me on. It's exciting to be here.
Yeah, and I'm excited to speak with you today. We're going to be talking all about zero-knowledge proofs, and you're going to kind of break that down for us.
Yep.
Before we get started with zero-knowledge proofs, and it's ZKPs for short, correct?
Yep.
Okay, before we get into zero-knowledge proofs, Evan, I want to hear a little bit about your background. How did you get involved with cryptocurrency and blockchain? And then we'll kind of dig into the topic of zero-knowledge proofs.
For sure. So my background is computer science. Someone who loved to program and code and think about technical systems problems as something that was fun. And shortly after college, myself and my co-founder started really digging into challenges around like mass verification of cryptocurrencies and the kind of trade-offs between can you scale a cryptocurrency while also making it accessible to a large number of people. And in doing so and thinking through that, we kind of arrived at applying zero-knowledge proofs as a direction to solving this problem. And so we've been working on this blockchain, Mina, that brings zero-knowledge proofs both for like this verifiability and scaling property, as well as the ability to program with privacy and verification.
Okay, yeah. Got it.
Yeah.
So let's talk about Mina real quick, because you're the CEO of Mina Foundation.
Yep.
So just briefly describe what Mina Foundation and what Mina Protocol is doing.
Yeah, so on the foundation side, we're just there to support the ecosystem in any way we can. On the protocol side, what can we say? Okay, so like basically, I think there's this new wave of programmability for blockchains. I will call it ZK programmability that's becoming available, and Mina is effectively like a leader in the ZK programmability space, where as a developer you can access all the features of zero-knowledge proofs, all the scaling, privacy, verification stuff. And as a user, you get all these advantages around your data being private, around being able to fully verify the blockchain, and through those having access to a much wider set of applications than you would on a traditional blockchain that doesn't have privacy built in.
Okay, got it.
Yeah.
So we're going to talk about some real-world Web3 use cases leveraging zero-knowledge proofs in a minute. But I also wanted to ask you, you are also the CEO of 01 Labs, is that correct?
So O of One Labs actually. It's a fun programming term that it's like slightly esoteric if you're not a programmer, but it's a
Explain it, because I'm not a programmer. I thought it was 01 Labs.
So there's something called big O notation,
okay,
which refers to the complexity of running an algorithm.
Okay.
And usually it's if something the list is n long, for example, you have to look at every item in the list. You would see that's O of n.
Okay.
Or if you had to look at each, if you had to do quadratic number of operations, it would be O of n squared.
Okay.
O of 1 is kind of this mythical thing where actually, independent of how big the input is, it's the same amount of time to run the algorithm, which usually you can't do, but you can with zero-knowledge proofs in some cases, because you can produce this proof once, then everyone verifies. So it's kind of a reference to that.
Okay, got it. Yeah. Good to know.
Yeah.
Now I know how to pronounce the name of the company correctly.
Yep. So originally, myself, my co-founder, I co-founded O of One, and I was CEO there. But as we went to launch the protocol, I went and founded the foundation, who's now doing broader ecosystem stuff, while the O of One continues to do development work on the protocol and on the programming language for zero-knowledge proofs.
Okay, got it. Let's talk about zero-knowledge proofs.
Yep.
What is a zero-knowledge proof?
So I think there's maybe two ways to approach this. I think a way that is both accurate and I think maybe helpful is to say that if you've heard of like public key cryptography or hash functions, zero-knowledge proofs is kind of a sibling to those. It's another cryptographic primitive you can use to do things with. Now, what are the things you can actually do with it? It's this way of producing an object, like a file, like a piece of data that you can hand off to someone else. And that person can look at it and say, I have seen this, and it is a proof of some fact. And what's cool about that proof is that it can say things about the fact without revealing underlying details about the fact. And it is very cheap to check. So I can make a big proof about all my personal history since forever. I can say, like, here's a proof about, if you add all these numbers up and you run them through this big machine learning algorithm that would take a long time to run, you get this result. I can hand that to you, and you can say, I trust the result of that, even though I haven't seen the underlying private information, and I can trust the result even though I haven't run this large computation. I trust the computation was performed correctly. You can think of the name like zero-knowledge proof. You believe the fact without having knowledge of the underlying details of the information.
So basically, is it like saying, I have a secret and I can tell you the secret, but but you won't understand like the data or whatever behind that? Is that?
Yeah, I mean, here's an example.
Okay.
Here's like the classic example people give. Like, I have a driver's license that has an age on it that was issued by some authority, and I can prove to you some authority has issued this license, and the year that authority issued is greater than 18. But I'm not going to tell you the actual specific age. I'm only going to tell you that there is an age that was attested to by an authority you trust, and that they wrote an age greater than 18, but I'm not telling you the details.
I see.
Yeah.
So basically it's data protection?
Yeah.
Okay.
And it has this other property as well, which is why I think, there's two things going on, which is I can also prove large amounts of facts about large amounts of data very inexpensively. Like for ZKEVMs, people are proving whole computations on EVM computations, but it's very cheap to check because of the zero-knowledge proof.
Got it.
Sense,
and EVM, that's Ethereum virtual machine for our listeners.
Exactly, yeah.
Yeah. Okay.
Yeah.
Got it. So what is the relationship between zero-knowledge proofs and Web3?
Yeah, I mean, it's the way I think about it is that Web3 is trying to do a lot of things right now. It's trying to be useful to users. It's trying to bring all these features. But I think that a core piece of technical, competency that's missing from it right now is privacy. Like all the applications we use today, even if we no matter how we think about them, they have some element of privacy. Even if you're trusting a central server, you're getting some level of privacy with respect to other users on the platform. But Web3, you can't do any of this right now. Web3, everything you do is 100% public. So I think with ZK, it has the opportunity to bring in building privacy into applications, which when you do that, it just unlocks so much more Web3 that you can do than otherwise. If you want to have a social network where not everything is public, you need zero-knowledge proofs. If you want to have any facts about your real-world identity, you need zero-knowledge proofs. If you want to not do finance where everything is completely in the open, you need zero-knowledge proofs. Yeah.
So zero-knowledge proofs, first of all, how long has this technology been around?
Yeah, it depends how you count it. It's been around in theory and prototype for around 40 years or so. But it was something that even though, in like the lab and in research, people were building with it for like a long time, it wasn't quite efficient enough to use generally. It was something where you could produce proof of an extremely simple fact, like the sum of a bunch of numbers, and it would take like hours to run. So it wasn't really, it was, in theory, it was sound and existed, but it wasn't practical yet. Mm-hmm. In the last 10 or so years, there's been a number of breakthroughs on the efficiency side as well as on the ease of producing the zero-knowledge proofs themselves, which has made it much more widespread and actually practical to use in general. Yeah.
So because the technology has been around for so long, this isn't a new concept, but it's matured to the point where we can start using it. Are zero-knowledge proofs being applied to like traditional finance businesses today? I mean, we don't have to, I'm assuming zero-knowledge proofs don't have to be applied to Web3 businesses. I think that it's adding an element of privacy to Web3, but can it just be applied to like traditional Web2 businesses?
Yeah. And I think this is actually where it gets really fun, because I think that in Web2 companies trying to use zero-knowledge proofs, they will kind of like start seeing why they should be building on public blockchains more, which I can talk about in a second. But I think there's like a fun thing that could happen there about pulling them into Web3 through zero-knowledge proofs, actually. Which anyway, but sorry, your original question was on.
So are Web2 like traditional businesses, like traditional financial institutions, can they use zero-knowledge proofs, or do we have to say, you know, a Web3 cryptocurrency focused business is using a zero-knowledge proof?
Yeah. No, so they definitely can. You can use zero-knowledge proofs without a blockchain off-chain. And I think this is starting to happen. It's a little early. Actually, this is a case where crypto has adopted ZKPs before other industries have. So Web3 is now on the cutting edge of zero-knowledge proofs. But they can be used outside of blockchains as well. And I think that's also a really promising direction for companies to privately prove facts to each other, to their users about their data, how they're operating, without disclosing all the information, but in a provable way. So I think that's like totally a thing.
Why is it that Web3 is kind of pioneering this implementation of zero-knowledge proofs versus these traditional businesses?
Yeah, I mean, crypto was like the place where there was an early need for this technology, where there was all this financial information flowing around, and there's already kind of a within crypto an ethos of privacy, of user sovereignty. The technology, like when it started to be applied in crypto, perhaps with Zcash like 8 or 9 years ago, it wasn't like, it wasn't like amazing at that time, but it worked for that purpose. And so crypto's like kind of been on like that very early part of the adoption curve where like they have big enough need for it. But I think it's getting to the point now where it's pretty generally usable. So it should be ready for other industries as well.
Got it. So my question is, it sounds like a revolutionary technology in terms of data protection, but are we at the point where we can start seeing zero-knowledge proofs being implemented into the mainstream, just given regulations?
Yeah. I mean, I think this is the thing that's really interesting is that they're actually extremely compatible with regulations if you're trying to build a company that isn't leaking a lot of data, which things like GDPR very much are, requiring you to be thinking about. It's very regulation compatible. Like you could even have, not only have you kind of privacy of data, so you're not revealing data necessarily, you can also prove you're complying with regulations to authorities without revealing your underlying database as well. So there's like a use case there. I think also there's just so many things within Web3 where if you just want to work with any data that's private, this is like a way to actually be able to do it in a realistic way.
So let's back up a little bit, because I think we're kind of like, I'm getting a little excited and I'm skipping on some key questions here. So we know what a zero-knowledge proof is. We know what the technology is capable of doing. Can you explain how it actually works and how is it different from a private blockchain network?
Yeah.
And maybe that's a silly question, but I don't know.
So here's how it works from the perspective of like a user. You have some data on your phone or on your device that's like signed by some authority or otherwise exists in some publicly verifiable manner. And your device locally will produce a proof in your browser or on your desktop or whatever of that information. And it will spit out this little proof, and then it can then send that proof to other parties. It can send that proof to a smart contract. It can send that proof peer-to-peer to another user. It can send that proof to a company. And then all of those other devices, those other blockchains or users or whatever, will check that proof. And they will say, the proof verifies, it's correct. And therefore I can trust what this user is attesting to. If that makes sense.
It does. Yeah. It does make sense. And so I guess that just ensures that data isn't revealed because the proof is trusted.
Yeah, and importantly, the data never leaves your own device in this example. So the data really, the only thing that leaves your device is a little bit of, the actual proof, which is only, it's very short. It's only a few hundred bytes or a few kilobytes of data that doesn't contain your original information at all. It's just a proof of the fact. So nothing leaves your device at all.
So this is all just basically mathematical proofs proving that something is truthful and correct. Therefore, a user doesn't have to reveal their data.
Yeah, and we can if we go a step down into the thing, what's really happening is any program you write that takes an input and has an output can be expressed as a long series of equations, and you can have a proof that says, I know a particular input that if I give it to this set of equations, the equations will all satisfy and they will all be correct. And then I can take that set of equations I've produced and I can sort of compress that down into a much smaller representation, which if I give to you, you can say, I know that you knew something which satisfied these equations, even if you don't know the original inputs that satisfied them. Mm-hmm. So that was quite, in the weeds, but that's what's happening under the surface.
Okay. What are the best use cases, in your opinion, for implementing zero-knowledge proofs? Would that be, you mentioned Zcash, for instance, as an early use case.
Yeah. So
are these financial use cases? Are these, what are the best use cases?
I think there's a few I'm quite excited about right now. I think one is you have all these institutions that I think could see a lot of advantages from crypto, but they don't want to, or they can't just dump all of their user data, all of their financial data onto a blockchain. That just for a lot of reasons doesn't work. But with zero knowledge proofs, they can start thinking about doing it. The other set of things I really like is on kind of the identity side of proving that I'm a unique human, proving that here's a bunch of facts about myself that I'm not going to tell you exactly who I am, but I'm going to tell you proof of those facts. I mean, those are both general, but I think those are the sets of things I'm most interested in at the moment.
Yeah, so that makes sense in terms of Web3, because a lot of Web3 is about digital identity and owning your data and keeping that data protected. So I can see why zero knowledge proofs are adding that layer into Web3 and making Web3 even better.
Yeah.
Got it. In terms of implementing this from a technical perspective, how does that work? Is it complicated?
So from the perspective, it's gotten pretty good, I would say. In the last year or so, there's a number of very high level frameworks people can learn that are pretty easy to get a hold of. Mina in particular has its programming language, Snarkyjs.
What is it?
Snarkyjs.
Okay, what does that mean? Can you break that down? Snarkyjs.
So the particular type of zero knowledge proof that Mina uses is called a snark.
Okay.
So ZK snark.
Right.
And then Snarky is the name of Snarkyjs is the name of us having our snarks be accessible in JavaScript effectively.
Got it. Okay, cool. Makes perfect sense.
Yeah.
Actually, it does.
It makes sense. Does. Yeah. So, it's all available right now in JavaScript / this other version of JavaScript called TypeScript that developers can start building with. Mm-hmm. And what's very cool about the place it's gotten to is you don't have to be a cryptographer anymore to use this stuff. You just have to be a programmer who understands the general concepts. And you can start building with this technology. So I don't know when this will exactly go live, but Mina's going to have its hard fork very soon where this will all be on Mainnet.
Okay.
And people can start building with it today on testnet and soon building on it on Mainnet as well. So it's all, it's all out there and working, and it's if you're a developer, it's pretty easy to get started with actually, which is very cool compared to where we were even a year or two ago.
Right. And it seems like ZK zero knowledge proofs are not, they're not specific to crypto and blockchain use cases. I think that's a really important point to make here, because although it's enhancing Web3, it can be applied for, just Web 2 or just traditional businesses, probably really good at enhancing just financial business models.
Yeah. And Snarkyjs actually does work like off chain without a blockchain. So if people do want to get started with it without connecting it to a blockchain, they can just do that. We think that companies are going to want to, once they start using this kind of privacy technology, have a shared, transparent, trustless place to put their zero knowledge proofs. And then they're going to reason out how you find a trustless, decentralized, shared place, and they'll arrive at, oh, actually, that's a blockchain. And then they'll post their zero knowledge proofs to blockchains. But we suspect people will get started with, some places will get started with these off-chain first before moving on-chain later.
I see.
Yeah.
Okay. You know, in 2017, there was a lot of talk. This is when I entered the industry. That's why I say 2017. There was a lot of talk of businesses using private blockchain networks.
Yeah.
In 2017, as far as I, can remember, I don't think I've ever heard the term zero knowledge proof, but I was hearing a lot about private blockchains. But it seems like with zero knowledge proofs, private blockchains are kind of, no one really uses a private blockchain anymore anyways. But has that taken away from that private blockchain mentality?
I think so. I mean, I think people kind of realize you don't get the full interoperability benefits of a blockchain, and there's a lot of other kind of overhead and hassle to building this private blockchain world that I think a lot of folks that maybe would have been interested in those are now being very interested in zero knowledge proofs as a way to kind of a more seamless way to build in private networks into blockchains. So I've seen that, yeah.
Okay.
It's a thing, yeah.
I was also curious to know more about, so you've said the technology has been around for 40 years or so, but now it's matured to the point where people can actually start implementing the technology.
Yeah.
So what's changed? How has it matured?
Yeah. I think for one, just like the proving speed got a lot faster. Again, from like, the complexity of proving a statement being, super, super long, it's gone down to maybe being around 100x slower than just running it natively on your computer. And, it's going to be around 100x. And that's like pretty good because our computer's so fast these days, 100x slower like isn't actually that bad. So that's like one big difference. Another big difference is the what's called the curve size. So like the length effectively of like the public keys from a user's perspective has been able to be much shorter from you'd be pasting public keys that are like, many, many, many lines long down to like a normal public key size. Another thing that's changed is the removal of something called a trusted setup. It used to be that whenever you were deploying a new zero knowledge proof, you had to associate it with some data that if someone found out about the data, they could forge fake zero knowledge proofs. So there were very complicated MPCs to produce this toxic data in a way that was not going to come back and break the zero knowledge proof later. But that's been fixed. So now they're like fully trustless. And you can deploy new zero knowledge proofs without this complicated setup. Also, there's a property called recursion of zero knowledge proofs, where zero knowledge proofs can verify another zero knowledge proof. So you can kind of stack and put them all together. That's been gotten to be fairly efficient in the last few years. There's a bunch of these things. Like, it's kind of all come together in the last few years as interest has grown to make this stuff efficient and easily usable and very trustless and all that. Yeah.
Have you personally helped with that growth? I'm just curious because you understand zero knowledge proofs. You have a background in this. Have you helped with the maturity of the technology?
Only very indirectly. I mean, I think like I've been fortunate to work with people that have been doing that work, like through OF1 Labs and through other places. But no, I'm usually at like this level of abstraction and have been not able to dig into it. But no, there's some great people that I've been able to work with that have pushed this stuff along, which has been awesome to see.
Okay.
Yeah. Let's
talk a little bit about AI and zero knowledge proofs. Is that even a thing? Like, do zero knowledge? I'm just pulling buzzwords out of the air, but no, I want to know.
I think yes.
Okay.
So this is something I've been thinking about a lot over the last like few months. Even before a little bit, my background before doing this was in like machine learning and AI. So it's been something in the back of my mind for a long time now. I think that there's one particular use case I think just like has to happen. I think it's like super important. And then there's a bunch of other use cases that are very cool. I think in particular, okay, we have like these very powerful AIs now that are able to produce content online, which seems like it comes from a human. I think if we don't already know yet, it's like, nation states and other large companies that have special interests are deploying and are going to be deploying fake humans online to push agendas. And that brings a question of how do you know whether someone is pushing an agenda online that is actually real or whether it's an actual human that you can trust. And this is where zero knowledge proofs come in, I think, in a way that's really useful. Being able to say, here's a proof that I am a unique person, that I only have one account on this platform, but I'm not going to tell you which human I actually am. I still want to remain pseudo-anonymous. And being able to put that together so you can verify people on these platforms are actually real is, I think, a useful thing.
So it's interesting that you're saying that. So the very first episode of Web3 Deep Dive was an interview with Chelsea Manning, which was amazing.
Yeah.
And she is a security consultant for a company that you may know called NIM. And she basically said in her interview that cryptography will help solve this problem of AI generating false information, which seems kind of like what you just said, except zero knowledge proofs. What's the difference between cryptography and zero knowledge proofs?
Yeah, so I'd be curious, like, what technology she had in mind in particular for that. Yeah, because zero knowledge proofs is like a subset of cryptography.
Okay.
It in all of its like, hash functions of public keys, all the other methods and primitives are all part of what cryptography is. So I wouldn't be surprised, but I wouldn't know for sure if like she kind of had a zero knowledge proofs in mind. But maybe, yeah.
No, I now I'm curious.
Yeah.
Gosh, I need to ask Chelsea Manning.
Yeah.
what type of cryptography, because it just seems like that's very much in line with what you just said. So are zero knowledge proofs being implemented today as we speak in the real world for certain use cases?
Definitely, yeah. Yes, I mean, we just had a number of early stage startups starting to build on Mina that are deploying these things for privacy in biotech, privacy in the energy sector, not to mention like infrastructure level things like ZK powered L2s, ZK powered identity projects. Like very much so.
Do the people that build on Mina, is it all zero knowledge proof projects?
Yeah, so I mean, they're all projects that have some way to, really benefit from using zero knowledge proofs in some way. But, it's people that that are coming at it from like knowing TypeScript, from knowing JavaScript, from being like really strong developers, but being able to access the technology that we've built through these kinds of existing programming languages without having to learn all the, depth and complexity and intricacies of the underlying zero knowledge proofs. The same way people use like a hash function library now without necessarily studying the intricacies of hash functions.
Mm-hmm.
If that makes sense.
Yeah. I'm just curious to see how zero knowledge proofs will advance, because right now with AI having this big moment and everybody's talking about AI, but now people are saying AI needs to be regulated and all of these things. It seems like zero knowledge proofs could kind of have this big moment in the near future, given that it's matured. But I do think that regulations are still a gray area.
I mean, I think so. Like, if we want to keep our data private from AI systems, if we want to prove things about ourselves and our content that prove it didn't just like come out of like, an AI that was pretending to be 10,000 different people. I think it hopefully it will and has the potential to like, yeah.
Yeah, I agree. I also wonder, with every technology, there are these bad instances and you have bad actors using the technology in, bad ways, I guess.
Yeah.
I wonder with zero knowledge proofs how that scenario may look.
Yeah, I mean, I think there's kind of a story about this that I'm not sure is fully accurate. Like, I think particularly this is like in practice, I think such like a very small percent of it's like from what I've heard, like the instances of bad activity happening in crypto is much less than the traditional financial sector. But zero knowledge proofs could be used to create more private transactions on crypto the way Zcash has. And some people don't like that. They think that private financial transactions are not good. I think that like from what the data I've seen, this is kind of overblown. It's a much smaller issue than some people might think. So there's that. But I think also with respect to this particular problem, there's ways to pull things like ZKKYC back into private transactions so that you can keep things private while proving you're a good actor, which is nice.
I actually think that's a really great use case, ZKKYC, so zero knowledge, know your customer, because the problem with decentralized platforms that require KYC is they're really not decentralized then if you know who your customer is.
Yeah.
But it's also at the same time really important from a regulatory standpoint to have KYC.
Yeah.
So with zero knowledge proofs, I think that can really be revolutionary in terms of things like KYC. Are we seeing that today where any exchanges or anyone is using ZKKYC? Did I say that right?
Yeah, definitely. I don't know if there's any live examples. I can tell you there are people that are working on this very seriously and that like it's going to be something in the nearest future.
Okay.
But yeah, I think it's like, a great, privacy regulation, all this stuff can coexist and because zero knowledge proofs are general, it can happen. So I think we'll see it pretty soon. I think it'll also be good.
Yeah. I'm very curious to see that because that's going to solve a lot of issues, I think.
Yeah.
But I want to go back. We've mentioned Zcash a few times, and some of the listeners may not know about Zcash. Evan, can you explain Zcash and I guess their implementation of zero knowledge proofs?
Yeah. I'll do my best.
Okay.
So
you'll do better. You'll do better than me.
Yeah, I could try.
Okay.
So I mean, they were one of the original people to deploy zero knowledge proofs in a production system, which was like super awesome and exciting. A lot of people that are advisors to that project are some of the people that made the breakthroughs in zero knowledge proofs that made them efficient enough to be deployed widely. So that's kind of part of that moment in time when it happened. Zcash is primarily focused on fully private transactions. So being able for, me to send you or anyone funds, but no one to be able to see any details whatsoever of that transaction. So that being completely private. Mm-hmm. So they're mostly focused on that kind of private payments use case. Whereas lots of what we've been talking about today is more general, what I call like ZK programmability, around building general purpose zero knowledge ZK apps that can do many different things. But Zcash has been like a pioneer. They've been doing this now for like a long time in bringing private payments that are provably private to the world. Yeah.
So that reminds me of something that I recently learned about when I was at the bank, which I try not to go to the bank very often. But anyways, I was there a few weeks ago. So there is an FDIC product now that it's basically a fake bank account number. It's like some random number that they give you. You have to pay for it. It's a service. So you get this fake bank account number and you can give it to someone to deposit payments into your actual bank account, but you're not giving them your real bank account number. I forget what it's called. Maybe it's called a UPIN, but it's like an actual legitimate thing now. So we're seeing that being used by the mainstream for traditional payments. How is that any different than zero knowledge proofs?
I think that this is an example where the same way that like your actual bank statement, is only, you and the bank can see it, but nobody else can see it. But it's not really private. It exists on like some big bank database somewhere that can get leaked, that can be messed with, whatever. Probably something similar is happening under the hood with the system you're mentioning, where from like a user perspective, it provides you not having to give out your actual account number, which seems really good. But under the hood, it's not fully private and it's still living on a database.
Got it.
I think one way I think about these is like, I think that, those steps are awesome from like a user perspective, but they lack kind of the interoperability that having full programmable privacy gives you, where great, they added that feature, but if it was in crypto, like anyone could have built it at any time and they could build a million other things that would be super cool. So that's, yeah.
You've mentioned interoperability a few times, and I think that's kind of important that we just touch on that real quick.
Yeah.
Just elaborate on interoperability. I'm assuming that's a big benefit of zero knowledge proofs.
Yeah. And I think like public blockchains in general, when you deploy an application on a blockchain, you're not just deploying it for users, you're deploying it for anyone else who wants to build on it. And everything can kind of be hooked up and connected. I think we saw with DeFi that being one of the big advantages of that ecosystem is that people just started building new components of DeFi and they all kind of got hooked up together into this big web of systems. So, I think that's one of the exciting things that you can do with blockchains. And then you can also connect blockchains together as well to have interoperability across chains, something else zero knowledge proofs is good for. But from a developer perspective, it's great because no longer is it just monolithic companies building monolithic verticalized products. It's like a web of people building together, building network effects off of each other, which is very cool if you're a developer and an early user of products.
Yeah, definitely. That's important. So we're going to wrap things up, but I want to ask you, what do you think the future of zero knowledge proofs are? You've mentioned that the technology has matured quite a bit.
Yeah. I think that we've started to see them being increasingly popularized through ZK EVMs. I don't know if people will be surprised, but I think we're going to see ZK increasingly take over crypto as, it'll be as big to crypto in a few years as EVM was to crypto. Like when EVM came out and programmability came out, like ZK is like such like a good fit for things crypto wants to do and needs to do. As well as I think it's an important time also with digital systems getting more and more powerful, with things like AI becoming increasingly powerful and even more powerful AI is on the horizon. I think it's a kind of a good time in a lot of ways, and crypto and ZK have a role to play, and I'm excited for ZK to, hopefully help in some of these areas. Yeah.
Right. Yeah. Yeah. And it's a real world technology that can also be applied outside of the Web3 sector, which is really cool. It's like a traditional financial institution. If they wanted to, they could implement zero knowledge proofs to make transactions private.
Yeah.
So I think that's a really important point to mention. Evan, so before we end the interview, do you want to kind of share some final thoughts? I don't know if there was something that I might have overlooked that you wanted to kind of call out.
I think just like if you're a developer, this stuff you can play with it now and it works. And it's also like a different way to thinking about building a program, which if you like that sort of thing is super interesting to think about. It's just like a different programming model, producing proofs of facts instead of just like running normal code. So, if you're a developer, I encourage you to check out some of this stuff. And if you're a user, to try some of the early products that are coming out. It's early, but it's all kind of happening. So it's a good time to check out the space. And
what are some resources? Should they go to Mina Protocol what's the website, or should they go, is there a white paper? I don't know.
Our Mina Protocol's Twitter, our website's good and fine. I think that really I would go to like the doc section of our website.
Okay.
And there are some articles explaining the kind of technical mental model of what is happening in ZK apps and in Mina with zero knowledge proofs that I would recommend people check out and I think is interesting.
Cool.
Yeah.
Well, I'll check it out because I want to learn more about zero knowledge proofs. It's really new to me, but it's interesting, and I'm not an expert on it, but that's how we learn. In 2017, I knew nothing about blockchain, and now I know more. The moral of the story. Cool. Okay. Well, thanks, Evan. This has been great.
Thank you. Yeah.
Thanks.